Hey, what's going on guys, Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And in this video, we're going to understand a new sorting technique which is called as heap sort. Now, if you're an old subscriber and if you've seen this DSA playlist, we have pretty much covered many other sorting algorithms like bubble sort, selection sort, insertion sort, merge sort, radix sort, etc. etc. All of those sorting techniques we've covered quite long back. However, heap sort I kept it for the end. That is because we first need to understand what is a heap data structure. So quick disclaimer before you proceed with this video. To understand heap sort, you need to understand what is a heap data structure, and we have pretty much covered all the aspects of heap data structure in previous video tutorials of this DSA playlist. So if you're someone who's new on this channel who's not seen the entire DSA playlist, please check out this playlist and cover the heap topic, the min heap that we've discussed in detail with theory and with all the operations. We've also implemented all those operations in the form of C++ programming, especially the extract, min and heapify operations. If you don't understand those operations, then understanding heap sort is going to be a little difficult because heap sort is pretty much based on those two operations. So make sure you watch those videos, and if you've already seen that, you're good to go. Things are going to be very easy in heap sort sorting algorithm. And with that disclaimer and with that introduction, let's start off with heap sort sorting algorithm. So a quick theory about heap sort. Heap sort is nothing but a comparison based sort which is based on binary heap data structure, and it is similar to selection sort where we first find the minimum element and place the minimum element at the beginning, and we repeat this same process for the remaining elements. So it's similar to selection sort, and because heap has a property that either the minimum value or the maximum value is always going to be at the root position depending upon whether it is a min heap or max heap, that property is going to be utilized in heap sort. So in previous tutorials we've implemented min heap, so we're going to use min heap over here also. And in min heap, remember, we have the property that the minimum value will always be at the root level, right? And what do we do in a sorting technique? We basically arrange all the values in an array or in a list in an ascending or descending order. And in our case, we're going to use the ascending order. So we already have the basic logic formed over here. We know that in a min heap, the minimum value is at the root level, and we want to do sorting, which means that we want to go from ascending to descending order. So the steps in heap sort go as follows. First, we take the size and values of the unsorted array from the user. Then we heapify that array. Heapify means creating a min heap or max heap from a given array. So when you take the inputs from the user, they will not be in a proper min heap format, right? When I say min heap format, it means that min heap has a principle that for a particular node, its children should be larger than that particular value. So let me just draw a quick example of min heap. So this right here is a binary min heap because the minimum value is at the root level and both its children are larger. It doesn't matter how they are arranged, right? So you don't have to be arranging 5 at the left and 8 at the right. In min heap, the only concept is for every node, its children should be larger than that particular value. So for 8, if I have over here 9 and if I have over 11 or 10, then this is valid. For 5, if I have 2 over here, then this is invalid because the root is 3 and 2 is smaller than 3. So ultimately we have to bring 2 at this level. So this is one step in heapifying the process, or when you insert a new node, you have to get it back to its appropriate position to, follow the principles of min heap. Now similarly, for max heap, the law will be exactly opposite. That is, the maximum value has to be at the top. Okay. But now since we are dealing with min heap, let's talk about min heap only. But the concept here is very clear. We are going to use this property of min heap. So we know that at the topmost value or at the topmost root level, we have the minimum value. So once we heapify the array, we will get something like this. And then we will call extract min operation, which will fetch us this root node and completely remove it off. So 3 will be printed. And then we will again heapify the remaining array. So again some minimum value will come over here. Then we will again call extract min. So step 4 is basically repeat step 3 till all values are extracted. So every time we extract a value, a minimum value will be extracted and it will be printed. So ultimately, we will get all the values in ascending order, And just to give you an example, this is how the working example would be. So taking the size and input from the user, let's say the size is 5. Let's say the user enters this array in any order. So you can see this is not in any sorted order, right? 7, 4, 3, 9, 8. It is not in ascending or descending order. Our goal is using this heap sort to sort this. So the sorted value, that the output that we want is 3, 4, 7, 8, 9. This is in proper ascending order, right? So this is what we want. So first thing we do is we take the size and input from the user, then we heapify the array. So when we heapify the array, we are basically creating a min heap, and the min heap would look something like this: 3, 4, 7, 9 and 8. Okay, this is how structurally or visually the min heap would look like. Now remember, we are implementing heap data structure using array, right? So even though the values are stored in the array, technically they are operating like a min heap. So visually you can represent them like this also, correct? Okay. Moving forward, the next step is extract min. So when you extract min, what do you get? You get the root value, which is 3. So you can see 3 is printed. So once you remove this, the next step is you heapify the array again, and now you are left with 4, 8, 7, 9. So recreating the heap with the remaining values. So this is how the heap would look like once you return 3. That is, once you call the first extract min and after you perform the heapify. So 4, 8, 7, 9 is left. Then again you will call extract min. This time you will get the top of the root, which is 4. So you got 3 and 4. You can see our ascending order is being created. So once you extract this, this will also be removed. And then again you can see you have to do heapify. So after heapifying again, you will be remained with 7, 8, 9. So this is how the heap would look like when you are left with 7, 8, 9 and when you do the heapify. Then again you will say call extract min. So you will get the minimum value, which is at the top root level, which is 7 this time. So 7 is printed. Similarly, you'll keep on heapifying and extracting till all the values are extracted, and the output is always going to be in ascending order because every time you're extracting the minimum value, right? So 3, 4, 7, 8, 9 is being printed. So this is what is going to happen in heap sort, and this is the step-by-step working approach. But now we need to have an algorithmic way of converting this, step-by-step process. So we need to have a step-by-step pseudocode as well for all these English steps, right? Because ultimately we want to write a C++ program to implement heap sort. So by the end of this video, we will also write a C++ program to implement heap sort. But let's first understand the pseudocode of Heapsort sorting algorithm. Okay, so over here is the Heapsort sorting algorithm. It is pretty simple because it consists of only two things. That is, we have to extract min, and every time you have to do the heapify. So extract min function is already there. I'll go step by step over here, but let's first take a look at what happens in the main function. So ultimately we are going to write a C++ program, right? And the execution of C++ program starts from the main function. So in the main function, what we will do, we will create an object of min heap type. Now again, for all of those who have not seen the previous videos on heap data structure, this is going to be a little difficult to understand. So please make sure you watch those videos, because we've already created the min heap class, which has all the data members, which are these 3 data members, and also all the member functions like insertion, deletion, heapification, extraction, etc, etc. So here we'll create a min heap object obj, and we'll take the size of the heap from the user. So s is nothing but the size of the heap. Then we will say obj.get unsorted array. So basically we are taking the input array from the user. Okay, so let's do this side by side by dry running this code. So let's say the size s that you're gonna enter is gonna be equal to 5. Okay, so this size will be assigned as the capacity and heap size both. That is because the user is gonna enter 5 values, right? So at step 2, you're saying get unsorted array. So basically nothing but take the input array from the user. So let's say the user enters some random 5 values. So let's note them down. So let's say the user enters 7, 4, 3, 9, 8. Okay, so this is an unsorted array. This is not yet a min heap because this is not yet following all the principles of min heap. Correct? Step 3 is we simply print out the array. Basically you'll print this as it is. So I'm not doing it over here. So 7, 4, 3, 9, 8 will be printed. So before sorting, you want to show the unsorted array, right? Now, step 4 is, as I mentioned, you need to first heapify this array. When you heapify this array, the minimum value will come at the root level, right? Because this is a min heap. And then you can do the extraction. So for the first time, when the values are all random, you have to heapify all the nodes. And that is the reason why you have to run a for loop. So currently, if I draw a structure of binary tree of this array, the values that we will have is 7, 4, 3, 9, 8. That's how you assign the values, that is the positional values of an array for a min heap, right? You go from top to bottom, from left to right. So right now, this is how the min heap is, and this is actually not a min heap, right? You still have to heapify this, correct? So now we have to heapify all the nodes, which means that we will have to start from the bottom and go till the top. That means we'll have to start the heapification process from the leaf node level, actually one level above the leaf node. That is because for this particular node, if you apply heapify, there is nothing below 9 and 8, right? So you don't have to apply heapify. This is already heapified. So you'll have to start the heapification process from one level above the root level. Okay? Always remember this. We have to start heapification from the bottom level to the top level, and we have to exclude the leaf level. So this is why we will run a for loop. We will say I is equal to s by 2 minus 1. S, as I mentioned, is nothing but 5, right? So I is gonna be 5 by 2 minus 1. So 5 by 2 is nothing but 2.5, and since this is an integer, you will exclude the fractional part, so it will be 2. 2 minus 1 will be 1. So I will be nothing but 1. So you'll start from I equals to 1 and you'll run till I is greater than equal to 0. So this is index position 0, 1, 2, 3 and 4. So you'll start from index position 1, right? We just calculated I equals to 1. Let me write I equals to 1 over here. Is I greater than or equal to 0? Yes. So you'll start heapification of this node, because you can see this has 2 children and this is one level above the root level, correct? Let's just say we had 2 more values. Okay, let's assume we had 2 more values, which means that the total size is going to be 7. So then the formula would become 7 by 2, which is 3.5, which means 3. 3 minus 1 is 2. So in that case, we will start heapification from this node because it has 2 children. So you'll have to make the comparisons of which one is smaller and get it at the top, correct? Heapification is nothing but creating a heap from the existing tree values. And in a min heap, remember the minimum value will always be at the top. So in case if there was 1 over here, this node would have come at this place, correct? So that is what min heap is all about. So first time we'll call min heap on this particular node because you're passing I. So min heapify is nothing but a function which we will create, which we have already actually created in previous tutorials. We are simply calling it over here. I'll show that function to you in a minute. And we are passing the index position I, which is nothing but a 1 for the first time. This node will be heapified. Right now there is no need to make any swapping over here. You can see it is already heapified. Then I will become minus minus, which means I will become 0. Is 0 greater than equal to 0? Yes. So now we will heapify this value, that is this node. So this root position 7 is definitely needs to be heapified because 7 is not the minimum value. So heapification will take first these 3 nodes and compare which one is the smallest. So 3 is smallest, so 3 should come over here and 7 will be swapped over here, correct? So ultimately we will get 3 over here, we'll get 7 over here, and in the array also this will happen, correct? So 3 will come over here, 7 will come over here, and now we have basically got our proper valid min heap. So this is a min heap. And then I will become minus minus, I will become minus 1, this loop will break out. And now we can call heap sort. Okay, so this is again our user defined heap sort function. So this will perform the heap sort as well as print the sorted arrays. So basically what it will do is these steps, correct? So let's see what heap sort does. First, we will create a temporary array with the same size. So capacity is 5. So temporary array will also be of size 5. Next thing, we will run a loop from 0 till 5, which means we will run from 0, 1, 2, 3 and 4, which means it will run 5 times. correct? And in that 5 times, the only thing that we are going to do is we'll say extract min. So minimum value first time will be 3. It will be put at index position 0 for the first time. Then we will print out this value. You can also print it outside the for loop, but right now I'm just printing it over here. So 3 will be printed first time. Then you'll come at the start of the for loop, j will become 1. J is less than capacity, capacity is 5, right? So 1 is less than 5. Then you'll go inside, you'll say temp of 1 is equal to again extract min. Now remember, when you call extract min is a function which already has heapify in it. So extract min will extract this value as well as heapify the array again. So you don't have to explicitly call heapify over here. So if you just want to see the pseudocode for extract min, let me just quickly show it to you. I have completely covered it step by step in previous tutorials, so we will not go in depth over here. So this is the extract min pseudocode. If you want, you can take a screenshot and you can dry run this step by step also again for practice purpose. But coming back to our heap sort code, it's basically just this for loop which will do the everything. That is because extract min is basically doing most of our work of extracting the minimum value and again re-heapifying the entire array. And then you simply have to print the values. So this is the entire heap sort. It is just few steps, but provided that you already have written the code for extract min as well as the heapification process and the initial steps where you take the size of the array from the user and perform heapify. Okay, so there is a little bit of initial processing, but the heap sort program is fairly easy. Now let's jump to the C++ code ID and see the program in working. Okay, so as you can see on the screen, we are in our C++ ID, which is dev C++ ID. We've already typed in quite a lot of code. This is all the code that we've been doing in the previous tutorials of heap topic. So I've just used that same code over here. There is a small difference in the constructor, the parameterized constructor. Here we make the heap size and capacity as same. In the heap videos, this heap size initially is 0. But because in our heap sort, we are going to take all the values from the user at runtime in one go, we are assuming that the heap size and capacity is the same. Okay, so that's one small difference. But apart from that, everything else is taken directly from that code. And don't worry guys, if you don't have this code, I'm going to be sharing this code on our official website. You can see a link in the video description to get this code. So coming down, we have the printing of array. We have the parent left right get min functions. Again, we've discussed all this in previous tutorials. Then we have the min heapify function and we have the extract min function. Lastly, we have the get unsorted array, wherein we say enter the capacity, that is the number of elements you want to sort, and then you take it from the user using cin. So this is where you take the input from the user, then you perform heap sort. Okay, so in the main function again, you declare s, that is the size of the min heap. You take the size from the user by saying enter the size of the min heap. Then you create a min heap object. So min heap is nothing but this class that we've created on top over here. This is the entire min heap class. So coming down, you take the unsorted array from the user. Let's say the user enters 74398. That is the example that we just saw. You print out the unsorted array. Then you perform min heapify on all the nodes except the leaf nodes by using this formula. You can also perform min heapify on the leaf nodes, it's just that it is not necessary. But remember that you have to do the min heapification from bottom to top, okay, not top to bottom. It won't work like that. And lastly, you simply have to say heap sorted array and call the heap sort, because in the heap sort function itself you're printing all the sorted values, right? This is where you're printing all the sorted values. So let's save this. Let's go to execute, compile and run. Let's see if this works. Okay, so this program is working. Let's enter the size of the min heap. Let's say 5. Let's enter the same values that we just dry run. 7, 4, 3, 9 and 8. When you hit enter, you get the unsorted array as it is 7, 4, 3, 9, 8. But the heap sorted array is 3, 4, 7, 8, 9, which is in proper ascending order, which means our heap sort is working perfectly fine. Now if you're a beginner and first time watching this video, please type this code at least once, but you can still get it from the website. Try it on your system. I'm pretty sure things will work perfectly fine. And this is where we've successfully understood and implemented the Heapsort sorting algorithm. Okay, so I'm gonna wrap up this video over here. I hope you understood the entire concept of heap sort. It is largely based on the heap data structure itself, that is the two operations of heap data structure, which is extract min or extract max. If you've implemented max heap, then the process will be exactly opposite. Basically, you'll print in descending order, or you can store the descending order values and print the array in reverse for the ascending order. Okay, but if you have a min heap, then it is fairly easy. But you need to understand the min heap operations, that is extract min as well as the heapification. Okay, so hope you've understood the entire tutorial of heap sort. If you like this video, if you've watched this so far, please give this video a like. Let me know in the comments how this video was. Do share it with your friends. And I'll see you guys in the next one. Peace.